Hello everyone, welcome back to the channel. Today we are taking a closer look at an important engineering and construction book titled Design of Earthquake-Resistant Structures * by S. V. Polyakov, published by Mir Publishers, Moscow. This book is a classic reference in the field of structural engineering and earthquake engineering. It was written to help engineers, architects, researchers, and students understand how buildings and other structures can be designed to withstand the destructive forces generated during earthquakes. Earthquakes are among the most powerful natural disasters on Earth, causing severe damage to buildings, bridges, dams, and infrastructure. The primary goal of earthquake-resistant design is not necessarily to prevent all damage, but to ensure that structures remain standing long enough to protect human life and reduce economic losses. In this book, S. V. Polyakov combines theoretical principles with practical engineering solutions, making it an important resource for anyone interested in structural safety and seismic design. The book begins by introducing the basic principles of earthquake engineering and explaining how earthquakes occur. Readers learn about the movement of tectonic plates, the release of energy beneath the Earth's surface, and the seismic waves that travel through the ground during an earthquake. The author explains how these ground motions affect structures and why buildings experience forces that can lead to cracking, deformation, or even collapse. Understanding the nature of seismic activity is essential for engineers because every design decision depends on accurately predicting how a structure will respond to earthquake forces. The book discusses various types of seismic waves and examines how soil conditions can influence the severity of earthquake damage. Through scientific explanations and engineering analysis, the author helps readers understand the challenges involved in designing safe structures in earthquake-prone regions. As the discussion progresses, the book focuses on the behavior of structures under dynamic loading. Unlike ordinary loads such as the weight of a building or furniture, earthquake forces are constantly changing and can act in multiple directions simultaneously. Polyakov explains the concepts of vibration, resonance, natural frequency, damping, and structural response. These concepts are fundamental because every structure has its own dynamic characteristics. If the frequency of ground motion matches the natural frequency of a building, dangerous resonance can occur, greatly increasing the risk of damage. The author demonstrates how engineers analyze structural behavior using mathematical models and engineering principles to predict how buildings will react during seismic events. Readers gain valuable insight into the science behind structural stability and earthquake resistance. A major portion of the book is devoted to the design principles used to improve the earthquake resistance of buildings. The author explains that earthquake-resistant structures must possess strength, stiffness, ductility, and stability. Strength allows a building to resist seismic forces without failure. Stiffness helps control excessive movement and deformation. Ductility enables structural elements to absorb and dissipate energy through controlled deformation without collapsing. Stability ensures that the structure remains balanced even when subjected to severe ground motion. The book discusses various structural systems, including reinforced concrete frames, steel structures, shear walls, and braced frames. Each system has advantages and limitations, and the author explains how engineers select the most appropriate solution based on local conditions and project requirements. The book also examines the importance of construction materials in seismic design. Different materials behave differently under earthquake loading. Reinforced concrete offers strength and durability, while structural steel provides flexibility and ductility. The author discusses material properties, structural detailing, and construction techniques that can improve seismic performance. Special attention is given to the connections between structural elements because weak connections are often responsible for catastrophic failures during earthquakes. Through numerous examples and engineering discussions, the book demonstrates how careful detailing can significantly improve the safety of buildings and infrastructure. Another important topic covered in the book is the design of foundations and the influence of soil conditions. Earthquake damage is often affected not only by the structure itself but also by the ground on which it is built. Certain soil types can amplify seismic waves, while others may experience liquefaction, a phenomenon in which saturated soil temporarily loses strength during shaking. Polyakov explains how engineers evaluate soil conditions and design foundations capable of transferring loads safely to the ground. This section highlights the importance of geotechnical engineering in the overall process of earthquake-resistant design. The author also discusses lessons learned from major earthquakes around the world. By studying real earthquake damage, engineers can identify weaknesses in existing designs and develop improved construction methods. The book presents examples of structural failures and successful earthquake-resistant designs, allowing readers to understand the practical consequences of engineering decisions. These case studies demonstrate that effective earthquake engineering is based on both scientific theory and real-world experience. The lessons learned from past disasters continue to influence modern building codes and engineering standards. What makes this book particularly special is its combination of scientific rigor and practical engineering knowledge. S.V. Polyakov was a respected expert in structural engineering, and his work reflects decades of research and professional experience. The book provides a systematic approach to understanding seismic forces and designing structures capable of resisting them. Although engineering technology has advanced since the book was published, many of the fundamental principles discussed remain highly relevant today. Students, researchers, and practicing engineers continue to benefit from the concepts and methodologies presented in this classic work. In conclusion, design of earthquake-resistant structures is much more than a technical textbook. It is a comprehensive guide to understanding the science and engineering behind safe construction in earthquake-prone regions. By exploring seismic forces, structural dynamics, material behavior, foundation design, and practical engineering solutions, the book provides readers with a strong foundation in earthquake engineering.